it's not realistic to modernize protocols like Kerberos or SMB or whatever to support MFA and device compliance and all of that stuff. But we have an option to control the network layer.
Hi, everyone. I'm Sean Dubey, Principal Technologist Americas, and welcome to the HIP Podcast. Despite all the security controls that have been built into Entra ID, the reality is that the identity system at the foundation of most enterprises, Active Directory, has minimal security controls built into it and was designed at a time that the only MFA available was smart cards. Microsoft has attempted to address this lack of strong authentication and access control for Active Directory on and off over the years, notably by using Entra ID-based security controls extended to on-premises using Zero Trust architecture and SASE, Secure Access Service Edge, to control access to on-premises servers. Microsoft Global Secure Access is an SASE platform that combines identity-aware, Zero Trust principles with network security, all managed from the Microsoft Cloud. It's new in just the last couple of months. My guest today, Christopher Brumm, presented about this at our HIP conference here in Charleston in a talk called Leveraging Global Secure Access to Fortify Hybrid Identity Management. Chris is a cybersecurity architect at glueckkanja AG, where he supports their SOC and clients with proactive and reactive identity security solutions. He's a Microsoft Security MVP and CISSP. Welcome, Chris.
Hi, thanks for having me.
Yeah, I'm glad to have you here. Glad to see you in person. After talking remotely, this is always better than doing this on a screen on either side of us. So, And so in your talk, you mentioned about ways to attack hybrid identity. And as a potential attacker, how would you attack a hybrid identity infrastructure?
Yeah, I think I would start on-prem. So I would start at something that is exposed to the internet. So like a VPN gateway. And then there are a lot of CVEs at the moment. We've seen many weaknesses over several vendors. It's exposed to the internet. Usually, it's old systems, fragmented systems. And it's not that hard to exploit these days. And if you look at current trends, this is the most common way for an initial access. So, and after that, when you have full network access, so VPN was designed for bringing the client in a situation as it is attached to the local network. So it's the 90s technology.
Right.
You can take over Active Directory if you know how. You don't have to know everything about Active Directory. You just need to know some tools to do it. It's very hard to protect Active Directory and configure it safe, so you know better than me. From there, it's not that hard to move lateral to the cloud environment, to move to Entra. So there are a lot of bad design decisions in the field, like synced admin accounts or bypasses for trusted networks. At the end, then there will be more lateral movement paths to cloud apps, back to on-prem or back to other cloud services, to infrastructures like Azure. So that would be my way. And I think this is the way that it has been chosen by many others so
Many
far.
threat actors would agree with you.
And
Well, you bring up a good point. And you're talking about a VPN, and basically once you've successfully connect to the VPN, it is as if you are on the corporate network with access to what the corporate network has access to. Yeah. And that is, after that, you work with an Active Directory, which is designed to be on, which assumes the corporate network is secure.
Yes. And a long time, having, I don't know, certificate-based authentication or MFA was good enough. But these days, you can, it's not that hard to phish MFA. And if you have successfully opened the VPN tunnel, you're basically in. And so better VPN solutions are doing SAML also.
Right.
And we have a short-lived token. But for convenience, many of the systems are configured that say, don't use that access token anymore after the first connection. They give you a cookie with this lasting for 24 hours or so.
Right.
And
once you have the cookie, again, well, and it is the difference. You're trying to apply these security controls to an architecture that's a quarter of a century old. So, but this brings up the question naturally then of the gaps. So when Entra ID came out, when Azure Active Directory came out, they designed it with a lot of security controls that were simply not available. And it's a different system entirely than Active Directory is. But what are the gaps between what you can do with access control and Entra ID versus what you can do with Active Directory? I know it's a big gap. But
there are a lot of gaps. But the first thing is when you look at Entra ID or app integration in Entra ID, Entra ID won't give you a token when you're not assigned to that app and when you not have passed conditional access. So for every app by itself. So if you have a VPN tunnel, you have only one of these authentications, and then you are done. So, and like Active Directory. So Active Directory won't filter. It will give you a TGS and hand it over to the application to take care.
Right. So you're talking about the granularity of the security controls in Entra ID, and the granularity being at a per app basis compared to Active Directory, which is you're either not authenticated or you are authenticated.
Yes.
And you have access to, well, whatever is configured for you to access as well. You have a big difference on here. And so what opportunities does that present to the attacker?
Yeah, I think if you are in, you can act as if you are in the local network and you don't have to do anything. There is not a layered approach or something. So, and even if we know that the user or client is already compromised, we have no option to kick them out. So, and if we want to replace the current architecture, we need something that has more a zero trust approach that allows us to have much more granular controls.
Well, and here we are talking about global secure access.
Yes.
So this came out a month ago. Was it formally announced, released was it public preview a month ago? Or
no, it's GA since
GA.
It's GA since last summer.
Oh.
Yes, but with a relative small feature set. So and they are giving out more and more features as public previews at the moment. I think it's important that it's GA because it's a network solution and people want to have SLAs on it and so on.
Absolutely. You don't want to have your access to on-premises servers, lock it down with access controls that are in public preview and have them go, oops, well, sorry, it was just public preview.
Yeah, and have fun.
Right, exactly. So what is global secure access about? What is it designed to solve?
Yeah, I think global secure access is let's say an umbrella. So there are two products in it. Global Secure Access is a security service edge. So it's the governor naming for it. It's this little brother of SASE.
Okay.
But without the SD-WAN part. So we're controlling the access from the client to resources in the internet, resources in SaaS apps, resources in the data center.
Right.
And there are two products in it. So one is Entra Internet Access, that is controlling the access to the World Wide Web. There's applications, Microsoft 365 and that part. And we have Entra Private Access for the data center part. And I think the main difference is that both of them are identity-centric. So not network-centric as the old solutions.
Right.
We have an identity-centric approach. And this is, I think, why I'm talking about this topic at an identity conference.
Zero trust.
Yeah, and it's designed with the zero trust principles in mind. So we talked about granular controls. It allows us, gives us the full capabilities of conditional access to enforce device compliance, risk-based rules, phishing-resistant authentication, all of that stuff, and brings it down to your network access.
Okay.
So it's not realistic to modernize protocols like Kerberos or SMB or whatever to support MFA and device compliance and all of that stuff.
Right.
But we have an option to control the network layer. When we look at Entra Private Access, it's just not just another VPN. So it gives us a very granular control for each session. We have a per app authentication like we have for SaaS apps. We can enforce very strong authentication methods.
Through conditional access.
And we have a complete assume breach approach. So if a user gets compromised, we can stop opening new connection and we can cut off the existing ones. So stuff like continuous access evaluation is built in. So and it can use the full power of all the Entra features that are there. And and I think a very basic thing is that we have another architecture because the client is not connecting anymore to your data center.
Right.
It's connecting to the cloud.
That was my next question: is how does this flow actually work? What is the user experience for this?
So we have a deep Entra integration. So usually we would have clients, Windows clients, Mac clients, mobile devices that have already a primary refresh token on the device.
Yes.
So we can use single sign-on with strong authentication and all of that stuff for single sign-on. So opening a connection is not something that a user has to do. Okay. So it just works. We have single sign-on under the connections, so it's tunneled. So the connections are tunneled and the tunnel establishment is completely in single sign-on. You can interrupt this if you want with conditional access as an example.
Right.
So you can say, I want to have a sign-in frequency every time, so for admin purposes also, or I want to enforce another a FIDO key as an example, then you would have an interrupt, but usually it just works. And then the client is connecting to the GSA, what's in your tenant.
Right.
If we have an example, so you want to connect to a domain controller and get a Kerberos ticket.
Right.
So then in the data center, there will also be a component called Entra Network Connector. That's a small agent running on a Windows server. And he's also connecting to the cloud. So you will have an outbound connection.
Okay.
It's a specific protocol, gRPC code.
And it's used as almost as a proxy on sitting in the data center, connecting back to Entra ID.
Yeah. So the Entra Network Connector is in line of sight to the resources and the domain controllers.
Right.
And so
has to be able to see all the domain controllers.
You could firewall this, but I think private access has also strong network control. So we don't need it in most cases. But the connector is doing an outbound connection. Right. So you could run your data center behind a NAT router.
Right.
So there is no exposed system. So there is nothing that is found in all that hacker libraries and so on and can identify via a fingerprint for this is something weak.
Okay.
And then it's tunneled. It's and it works like, I don't know, an SSH tunnel or a SOX proxy. Or so we have an application layer tunneling, and the network connector is establishing a new connection to the resource. So for the resource, for the domain controller, it looks like the connector is establishing the connection.
I see, like it's coming from the agent, is what you're saying.
Yeah.
And this is a tunnel only to the particular resource in question
Yes.
that the user can access.
Yeah, and for every new connection, the service will have a lookup. Okay, do I use this resource? Is it configured? Is it mapped to a specific app in Entra? And for that app, there is a user assignment, and there are maybe a specific conditional access policies. So
right,
and this is why we can configure on a per app basis. So for this resource, it's okay if you have your usual authentication,
right.
And for this,
but for the secure resource, we have some kind of step-up authentication.
yes.
So what about ordinary or legacy access to, again, this can be used for more than just domain controllers, but we're focused on talking about domain controllers here. How do you prevent legacy access from happening? In other words, if somebody tries to RPC into it or use some kind of, one of Mark's sysinternal tools to connect to the domain controller, how do you prevent that?
So yeah, we can control the network layer. So, and we can try to enforce all the traffic to go through GSA.
Okay.
Then we will have a granular control on the network layer.
Okay.
So, and we can control which kind of devices are able. So we can use device filters, so like admin workstations.
Right.
So this is one thing, but this requires that you have a separation between your client network and your server network.
Right.
Some companies are already there. They have modernized their environments. They have kicked out the clients of Active Directory, and they have Android clients, and they clients living in, I don't know, guest Wi-Fis. But often there are still resources, or the clients are connected when they are on-prem. And then this is something new. You could install agents on domain controllers that can filter.
Okay.
And that can enforce that for specific service principal names, the traffic goes through GSA. So we can have the controls of conditional access, even if the client is in line of sight to that resource.
Okay.
If it goes via Kerberos.
So I see where you're going on this. What about what are the installation requirements, which could be the $100,000 question. What is needed to be able to implement global secure access?
You should have your authentication and client management in place. So if you have invested in, Intune, if you have invested in an MFA rollout, and so you could use all of this. You need to install an agent on your devices.
Right.
It will be maybe part of the operating system in future, but for now you have to install an agent. So, on the server side, if you want to connect a data center, you need to install these agents. So, and this is done in, you need a Windows server. It should have two, obviously.
Right.
And then it's half an hour or so.
But it's not requiring, it's not like you have to have, every domain controller has to have Windows Server 2025 or anything like that.
No.
That's a big deal.
It's completely independent from your environment. If you don't have any Active Directory there, it will also work.
Right.
So
right for your other servers.
So yeah, my colleagues that are providing managed service in Azure,
yes,
there is a big demand for make this accessible. And in the past, we had some stuff that the users connected via the on-prem VPN, and then with a side-to-side tunnel to Azure.
Right.
Or there were Azure VPN So, and now we can just install or another Entra connector
Right.
group. So you can have multiple of these groups.
Right.
So this is also a difference to a classic VPN solution. You can have your Entra network connector group in Japan, in Europe, in the USA, and it's transparent for the client because the client is all only connecting to the cloud.
Right.
And the connectors are also connecting. And so it will take the closest connector to the resource.
Right. Right. Okay. So this is providing secure access to on-premises resources that requires no upgrades on premises,
Yes.
which is quite a change from the past. And the Entra components are all
Yeah, you need some licenses. So
Yeah.
obviously,
right.
and you need you need to take care for the Windows servers where the agents are running. So
Right.
you need to update them and harden them and all of this. So, but this is if you're running servers, you should take care of them.
Well, so here's the call to action for our viewers: is if this is intriguing to you, and it really ought to be, you should watch Chris's talk on the HIP conference website, where he dives into much more detail about how to make this work and what its advantages are. Well, thank you, Chris. I appreciate it. Global Secure Access is desperately needed to help protect access to the domain controllers, and it'll be interesting to watch how it develops and how it's adopted.
Yeah, me too. Okay.
And everybody, thanks for the podcast. Thanks for watching, and we'll see you next time.